So this is a backup lecture for those students who had missed the first lecture on matrices. So what is a matrix? Have you heard the term matrix? Matrix is basically a rectangular arrangement of numbers or objects in rows or columns. It's a rectangular arrangement of numbers or objects in rows or columns. For example, I start with a simple example. Say there are three students, Ram, Mohan and Shyam. There are these three students that I have. They have certain number of notebooks and certain number of pens. Okay, now Ram is very studious, so he takes 10 notebooks with him and 5 pens. Now Mohan does not like to study much, but he goes to study. So he comes with 5 notebooks and 3 pens. अब श्याम को तो बिल्कुल ही पढ़ना पसंद नहीं है, घर से स्कूल जबरदस्ती भेजे गए हैं. So he goes only with 2 notebooks and no pen. So this is the particular information that I have about Ram, Mohan and Shyam. Now this information, if I want to represent it in the form of a matrix, that means I want to represent this information in the form of rows and columns. The horizontal lines are called the rows and the vertical lines are called the columns. So I represent this particular information 10, 5, 5, 3, 2 and 0. This is how I represent this particular information. So how many horizontal lines do I have? I have 3 horizontal lines over here, so I have 3 rows. And how many vertical lines do I have? I have 2 vertical lines, so those are 2 columns. So number of rows into number of columns, there are 3 rows and 2 columns. So number of rows into number of columns gives me the order of the matrix. Gives me the order of the matrix. Number of rows into number of columns gives me the order of the matrix. So the order of this matrix is 3 into 2. Now here if I add up the first row, I would get the total number of notebooks and pens that together Ram has. If I add up the first column, I would get the total notebooks that Ram, Mohan and Shyam have. Now if the same information I want to represent it in another form, how do I do it? I can invert it. I can invert the rows and the columns. That means the first row becomes the first column. So 10, 5, 5, 3 and 2, 0. So now how many rows do I have? I have 2 rows and how many columns do I have? I have 3 columns. So the order of this matrix becomes 2 into 3. Now here if I add up the first row, that gives me the total number of notebooks that Ram, Mohan and Shyam together have. So this particular information I have represented it into a 3 into 2 and 2 into 3 matrix. If you see the number of elements, how many number of elements do I have? 1, 2, 3, 4, 5 and 6. So number of rows into number of columns also gives me the number of elements present. Also gives me the number of elements present. For example, here the total number of elements present were what? 6. So what are the possible orders that I can have? I can have a 3 into 2 matrix, a 2 into 3 matrix. I can also have a 1 into 6 matrix and I can also have a 6 into 1 matrix. If a matrix, for example, has 13 elements, then what are the possible orders that I can have? I can have a 1 into 13 matrix and a 13 into 1 matrix. That means all the factors that you can have. All the factors of 6 was what? 3 into 2, 2 into 3, 1 into 6 and 6 into 1. But here 13 was what? A prime number. So what were the possible orders that I could have? 1 into 13, 13 into 1. I give you one more example. Say for example I have 24 elements. Then what are the possible orders that you can have? You can have 1 into 24, 24 into 1. Then what can you have? You can have 2 into 12 and 12 into 2. You can have what? You can have 3 into 8 and 8 and 6 into 4. So how many possible orders you can have? You can have 8 possible matrices of this particular kind. So if a matrix has 24 elements, then what are the possible orders? 1 into 24, 24 into 1, 2 into 12, 12 into 2, 3 into 8, 8 into 3, 4 into 6 and 6 into 4. So this was exercise 3.1, question number 2. This was exercise 3.1, question number 2. Now we would move ahead in the next video. Ahead now. Now we have something very important. Where is matrices used? Have you ever thought about this? I taught you matrices, but where is it used? Matrices is something very important which is used in our day-to-day life. Matrices are used in robotics. They are even used in medical, when we are finding out MRI, CT scans, Photoshop, Adobe, all this uses matrices. You know, even one very common thing where matrices is used, Google Map, to trace our location, it uses matrices. So matrices, the position is something very important which matters. Now here if you see, this is the notation form of writing down a matrix. A is equal to Aij m cross n, where m cross n is the order of the matrix, which is number of rows into number of columns. And I and j, I stands for row and j stands for column. For example, if I have a matrix over here, I have a 2 into 3 matrix. Now if you see, 2 is at which position? 2 is at the position A11. This is where? First row, first column. So that is what? A11 key position. If you see 6, 6 is at which position? 6 is where? It's in the first row but in the third column. So what is its position? A13 key position. Now if you see 3, 3 is at which position? 3 is in the second row and the second column. So it is at what? A23 key position. So this is how positions matter over here. So matrices positions is something very important. Now for example, if you have to construct a 2 into 2 matrix, construct a 2 into 2 matrix such that Aij is equals to I plus j. This is given to me in the question. That means I'm supposed to construct a 2 into 2 matrix such that Aij is equals to I plus j. So 2 into 2 matrix means 2 rows and 2 columns. So A11, A12, A21 and A22. So I have 2 rows and 2 columns. So this is what I'm supposed to construct. Now A11 is something what I will have to find out. Now it is given to me in the question that what? Aij is equal to I plus j. This would be given to you in the question. Now this can differ. It can be I plus 2j ka square. It can be I into j. Now this differs from question to question. And construct a 3 into 3, 3 into 4, any kind of a matrix is what he can ask you. So A11 means what? I is 1 and j is 1. So how much is A11 that I get from here? 2. Now A12, I takes up value 1 and j takes up value 2. So 1 plus 2, that is 3. Then A21, now I is 2 and j is 1. So how much do I get from here? 2 plus 1, which is 3. And A22 means what? I is 2 and j is 2. So 2 plus 2 is 4. What I get from here? Now I represent it back in the form of the matrix. So what do I get? 2, 3, 3 and 4. And always we mention the order of the matrix. So that is how you can construct any particular matrix over here. So this was our topic on constructing a matrix. So based on this you would do exercise 3.1, question 1, question 3, question 4, third part, second and third part, and question 5 for your homework. This is your homework to construct a matrix. Equality of two matrices. When are any two matrices said to be equal? First condition is that their orders should be same. That means you can compare a 2 into 2 and a 2 into 2 matrix only, or you can compare a 3 into 3 and 3 into 3 matrix. You cannot compare a 2 into 2 and 2 into 3 matrix. So first condition is their orders should be same, and second condition is that their corresponding corresponding elements should be equal. Like for example, I take up a question and explain it to you. This is question 7 of exercise 3.1. Two matrices are given to me and I am supposed to find A, B, C and D. That is my question over here. So first of all, let's see their orders. This is a 2 into 2 and yes, this is also a 2 into 2 matrix. So their orders are same over here. So what can I do? I can compare both the matrices. Now how do we compare the matrices? We equate the corresponding element to the corresponding element. That means A11 should be equal to B11. So first of all, I'll say as the two matrices are equal, so their corresponding elements would be same. So now I equate over here, A minus B should be equal to -1. Then A12 would be equal to B12. So 2A plus C would be equal to 5. 2A minus B would be equal to 0. And 3C plus D would be equal to 13. So I solve the 4 equations from here. Solving the simultaneous 4 equations. Solving the equations, I get the values of A, B and C. So A takes up value 1, B takes up value 2, C is 3 and D is 4. That is how you can solve any particular question. You can and get the value of any x and y by equating the two matrices over here. So you would solve question 6 and question 7 of exercise 3.1 for your homework. Solve question 6 and 7 of exercise 3.1 for your homework. We have learnt matrices, so now if we learn anything new, we have to learn addition, subtraction, multiplication, division. All these properties is what we have to learn. So we will be learning addition, subtraction and multiplication, but not division. There is nothing like division of matrices. You cannot divide two matrices. Please do remember, there is nothing like division of matrices. Now how do we add? When can we add? We can add only two matrices if their orders are same. This is something very important which you need to remember. When can I add two matrices? Only if their orders are same. And how do we add? We add the corresponding elements. For example, if I have a matrix A as 1, 2, 3 and 4 and I have a matrix B as A, B, C and D. So both are 2 into 2 matrices, so I can add them. Now how do I add A plus B? Would be what? 1 plus A. I add A11 to B11. Then I add A12 to B12. So 2 plus B, 3 plus C and 4 plus D. That is how we add two matrices, and the resulting matrix that I get would also be what? A 2 into 2 matrix. Now how do I perform subtraction? Subtraction is also done in the same way. Matrix addition is something very easy. So now how do I subtract? 1 minus A, 2 minus B, 3 minus C and 4 minus D. That is how I perform matrix subtraction. Now there is something called scalar multiplication. If I need to do 3A, so what would 3A be? I would be multiplying this A matrix with 3. That means I would be multiplying all the elements of the matrix with the number 3. So this would become what? 3, 6, 9 and 12. So that is scalar multiplication. Every element of the matrix gets multiplied with the scalar. Then you can perform 3A plus 2B or 3A minus C. Accordingly, you can perform any particular operation that is given to us. So based on this, we will be doing exercise 3.2. Exercise 3.2, question 1, first part, third part, and question 2. Question 5 and question 6 for your homework. This is your homework. So till here is what you had missed in the first class. After this, I have posted on the group itself what topics we would be covering. So till here it was for all those students who had missed the first lecture.